right, Longhorns, we're on test 6.1 review, and we're going to start with question number 1. In this particular question, we have to do a process called completing the square, which you may remember from when we worked in quadratics. So the way we're going to do this is we're going to take our x terms, which we're going to start with x squared, and we're going to subtract the 8x from that, and from here we're going to complete the square. So we're going to make a square out of this. So plus something. And then we're going to also do that with the y values. So y squared minus 4y. And then we're going to make a perfect square out of that, plus something, equals, and then we're going to move this positive 18 to the other side of the equal sign, and we're going to make it negative 18. Now, when we find these values that go in these blanks for these perfect squares, we're going to have to add them also to the negative 18. So here I'm going to take my negative 8, I'm going to cut it in half. That's going to give me negative 4, and I'm going to square it. That's going to give me 16. Well, I also have to add 16 to my negative 18. Next, I'm going to cut my negative 4 in half. This negative 4 right here, I'm going to cut it in half. That's negative 2. Negative 2 squared is 4. So I'm also going to add 4. All right, so what I end up with, my perfect squared binomial that's created by this x squared minus 8x plus 16 is x minus 4, the quantity squared. Because remember, when we cut this negative 8 in half, we got a negative 4. So that's what's going to go inside our binomial. And then we're going to do the same thing for the y. So we cut the negative 4 in half, which was negative 2. And then we squared it. And that equals, now I've got to sum up what I've got here. I've got a negative 18 plus 16, that's negative 2, plus 4, that's 2. And that would be my final answer. This is actually the equation of a circle with a radius of square root 2. All right, the next problem we're just classifying these conic sections that are in general form. So my first conic section, I look to see if I have two terms that are squared, and I don't. I only have one squared term. Just this y is squared. Nothing else in here is squared. So when that happens, I have a parabola. Parabola. Okay, in my next term, I look to see what I have here. And I have two squared terms. I have an x squared and a y squared. I have a plus sign here, which means it's either a circle or an ellipse, but my coefficients are different. If your coefficients are different in front of your x squared and your y squared, then you've got an ellipse. Okay, and the next one, let's move this up a little bit. We have two squared terms. Both of these terms are squared, and we have a plus sign. So we know it's not a hyperbola, so it has to be a circle or an ellipse, and the coefficients are the same. So if the coefficients are the same, that means that that is a circle. And in problem D, we have two squared terms. We have two squared terms here, but one of these squared terms is negative. This one is negative. That means we're going to have a minus sign between our squared terms. And if we have a minus sign, that's a hyperbola. Hyperbola. Okay, question 3. Let's move right along here. Question 3. Identify the center and the radius of the circle. Well, HK is our center, HK. So the center is going to be, remember we got to change the sign, -1, 3. And our radius is the square root of 9. So to find the radius, we take the square root of 9. So that's going to be 3. And that's it. All right, for problem 4, we're to find the center and the vertices of the following ellipse. So once again, HK is going to be our center. So again, we need to change the sign. So -3, 1 is the center of our ellipse. And the vertices, we're going along the x value to the left and right 4 units. And we're going along the y value, the y direction, we're going up and down 4. So this is going to be our major vertices. So this is what we want to identify here. So what we're going to have to do is we're going to have to add 4 to this one and subtract 4 from it to get the next, to get the vertices for this ellipse. Okay, so -3 is going to be our x value. So we're not going to change the x value since our major axis is along the direction of y. And we're just going to add the square root of 16, which is 4. We're going to add 4 to 1. That's going to give us 5. And we're going to subtract 4 from 1, which is going to give us a -3. So our vertices are -3, 5, and -3, -3. And if you wanted to draw a picture of that or graph it on the side for scratch, you could do that. So -3, 1. Up 1 would be right here. And since the major axis is up 4 units, so if this is 1, 2, 3, 4, if I go up 4 units, that puts me right here. Well, that point is -3, 5. And if I go down, 1, 2, okay, 1, 2, 3, 4, that puts me at -3, -3. So if you need to draw a picture, you can do that. This would be our ellipse right here, if that helps you. Otherwise, all you have to do is add or subtract from whichever value your major axis is on. Okay, in question 5, we're graphing and writing the standard equation for this parabola that has the following characteristics. Its vertex is 0, 0, and the focus is 0, 3. So, first of all, let's start by graphing in our vertex, which is right there at the origin, and our focus. I'm going to do a different color, 0, 3, which is right here. Now we know that the parabola opens upward because the focus is always on the inside of the parabola. And we know that this value right here between the vertex and the focus is 3. So we know that P is 3. So we're going to use our parabola equation. Since our parabola is opening up and down, we're going to have an x squared parabola. So this is going to be x minus 0 squared equals 4 times p. Well, 4 times 3 is 12. So our 4p is 12. And then y minus 0 again because our k is 0. So y is 0 k is 0 and x is. H is 0 and k is 0. So our hk is 0, 0. And so that's it. So that's how you're going to write the equation for this parabola. All right, for the next problem, it's write the equation of the hyperbola with vertices at 15, -3 and 3, -3. The value of a is 6 and the value of b is 8. So since we already know the value of a and b, really all we need to find is the point in between these 2 points. So we can use the midpoint formula for that. Since we already know a and b, we can just use the midpoint formula. So we're going to add our x's together and divide by 2. And we're going to add our y values together and divide by 2. Hold on, this is not supposed to be a plus sign, that's a comma. So our y values are -3 and -3. And divide by 2. All right, so 15 plus 3 is 18, divided by 2 is 9. And -3 minus 3 is -6, divided by 2 is -3. So our center is 9, -3. So we need that because that's going to be the midpoint between these 2 points, which is also our center. Now we're ready to write our equation, now that we have the center. So our equation is going to be based on which way the hyperbola is opening. Well, since these y values aren't changing, that means we have a hyperbola that is opening sideways like this. And if we have a hyperbola that's opening sideways, then the x value is going to go first, or the x term. So x minus 9, the quantity squared, minus y plus 3, the quantity squared. And now my a squared always goes under the first term. So a is 6. So a squared is 6. 6 squared, or 36. And 8 squared is my b. So 8 squared is 64. And that's going to be equal to 1. So in a review real quick here, this 9 and -3 comes from the center point. So this is my h, and this is my k. And that's going to be the center. And so the center values go right here in my equation. It's a hyperbola, so this is going to be a minus sign. And then my a value goes underneath the first term, and my b value goes underneath the second term. And these are both squared. So I have to take my a value and square it, and I have to take my b value and square it. And I'm done. All right, in the next problem, we are filling in the table for this parametric set of equations, and then we're going to graph them. All right, so all I'm doing is putting 0 in for t in both of my equations, and then I list my x values and my y values. So for my x values, I have 0 for t, so the first value is going to be -1. 1 minus 1 is 0. 2 minus 1 is 1, and then 3 minus 1 is 2. So these are my x values, -1, 0, 1, and 2. And then I plug t in for the y equation. So 0 times t is 0 times 2 is 0, plus 1 is 1. 1 times 2 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. And then 3 times 2 is 6, plus 1 is 7. And now I'm going to graph these points. So I'm going to move over here to the graph, and I'm going to make it a little bit smaller so we can see everything together. There we go. And then I'm going to graph the x and y values, and I'm also going to use arrows to show which direction we're going. So -1, 1 is right here, and then 0, 3, and we're heading in this direction. 1, 5 would be the next one. So you're going to make sure you put arrows in here. 2, 7. And that's it. It's graphed. All right, for the next graph, t is actually an angle measurement. So in our table, we have the angle measurements, 0, pi over 2 pi, 3 pi over 2, and 2 pi. So we're going to use the values from our unit circle to help us find the x and y values for these columns. All right, so if I'm looking at my first equation, I need the cosine of t. Well, if t is 0, I need cosine of 0. Well, cosine of 0 is 1. So 1 times 2 is 2, and 2 plus 2 is 4. So my first value for x is 4. And then I'm going to do the y value. The y value is, for sine of 0 is 0. So 0 times 3 is 0. 0 minus 1 is -1. And then I'm going to do pi over 2. So the values at pi over 2 is the value there at that angle is 0, 1, where cosine is 0 and sine is 1. So if cosine is 0, then 0 times 2 is 0 plus 2 is 2. So my x value here is going to be 2. And then my sine value is 0. My sine value is 1. So 1 times 3 is 3, and 3 minus 1 is 2. So I have a 0.22. At pi, the cosine value is negative 1. So negative 1 times 2 is negative 2. And 2 minus 2 is 0. And the sine value is 0. So again, we're going to have a negative 1 here. And then 3 pi over 2, my cosine value is 0. So 0 times 2 is 0. That's 2. Okay. And then sine is negative 1. Negative 1 times 3 is negative 3. Minus 1 is negative 4. And then 2 pi, we're back to the same where we started. So we're back to the beginning. So 4, negative 1. And now I'm going to take these values and I'm going to graph them over here on my graph. And I want to make sure that I put my arrows in the correct direction where we need to go. So we're going to start at 4, negative 1, which is right here. Then I'm going to go to 2, 2, right here. So I'm heading in 4, negative 1, 2, 2. I'm heading in this direction. 0, negative 1. Okay, so we're, 0, negative 1. There we go. Got off track here a bit. Let me erase that. So we're coming back down this way. And then 2, negative 4. That's down here. Coming back down. And then 4, back to 4, negative 1. Okay, so here's our ellipse, and we're heading in the counterclockwise direction. All right, in the last few problems, we're going to eliminate the perimeter and write in the form of a rectangular equation. So I'm going to make this a little bit bigger. All right, so the first thing we need to do is solve for t in one of our equations. So I'm going to solve for t in this equation right here. I think it'll be easier to solve for t for this one. So I write down my equation here for my work. And the first thing I'm going to do is subtract 1. And then divide by 3. Okay, so those 3's cancel out. So I get t equals x minus 1 over 3. Now that's what I'm going to substitute into my other equation. So into my y equation, I'm going to substitute x minus 1 divided by 3. Let me put a big parentheses around this. Squared plus 5. And that's it. That's my rectangular equation. All right, question 10. We have x equals negative 2t and y equals t minus 4. So I think the easiest one to solve in this one would be the y. So I'm going to solve for y this time. Y plus 4 equals t. And I can substitute that in to my x equation. X equals negative 2 times y plus 4. And that's it. So that was pretty easy. So you're probably thinking, yeah, but Ms. Stiles, couldn't we have solved for t in the first equation? Yes, we could have, and we would have gotten that, that x divided by a negative 2 is equal to t, or negative x over 2, or negative 1/2 x. And then we could have substituted that in to the other equation, and we would have gotten this. Negative x over 2 minus 4. So that would have worked out also. So either one of those would be perfectly fine rectangular equations. In the last equation, we need to use the Pythagorean identity of cosine squared t plus sine squared t equals 1. So let me write that down. Cosine squared t plus sine squared t equals 1. We're going to use this identity to help us write this equation. And so the first thing we need to do is solve for cosine t and sine t. So I'm going to write these together like this. And I'm going to write my y equation over here as well. Let me erase this. Okay, so we have y equals 4 sine t, and I'm going to solve these together. So I'm going to solve for cosine t by dividing both sides by 3. So I get x over 3 equals cosine t. And I'm going to do the same thing with this y. I'm going to divide by 4. So I get that y over 4 equals sine t. So now all I need to do is put them together in my Pythagorean identity. So cosine squared t would look like this. X over 3 squared plus y over 4 squared equals 1. And then if I simplified that, I would just have x squared over 9 plus y squared over 16 equals 1. And that would be my equation in rectangular form, and I'm done. So good luck on your test. I wish you lots of luck. I hope you all get hundreds and fives, and just make sure you practice that first problem, completing the square, so you can make sure you get your extra 5 points. Good luck, Longhorns.